Today we are talking about how to find the area between two curves. Area between two curves. So, we have been doing the area under a curve up until now. Now we're going to talk about if there's two graphs and you want to find the area between them, how do you do it? So what I need you to do first is to draw this graph as close to mine as possible. So draw yourself an XY axis. I need you to draw a curve that starts in quadrant 3, moves over to quadrant 4, and ends up in quadrant 1 like so. Call it f of x. And then underneath that curve, you're going to draw a second curve that kind of runs parallel to it. It doesn't have to be exactly the same, but it has to end in quadrant 1 also. We're going to call it g of x. And I want to find the area between those two graphs from A, which is over here, to B, which is over here. I'm purposely drawing a ugly looking graph at first because it'll cover both the easy, medium, and hard stuff. Okay. What I need you to do after you draw that is just to think for a minute. I want you to think back to when we started doing areas in the first place. Back before we learned what a definite integral was. What geometric shape did we divide something like this into in order to estimate what its area was? Trapezoids was one of them, but before that, rectangles. So what I want to do is I want to take this thing and I want to divide it into rectangles vertically. So what I want you to do is take a pen or take your pencil and draw vertical lines connecting the two curves. Kind of close together, all the way from one end to the other. Because the smaller the rectangle, the better of an estimate it's going to be. After you do that, write this down. To find the area between curves, divide the area into thin rectangles. To find the area between curves, divide the area into thin rectangles. That's what we just did. How many? But do you agree with the statement, the more rectangles you have, the better of an estimate of all the area it's going to be? Yes. Because because it's curved, you're going to have to chop off a little bit at the top and the bottom to make a true rectangle. Okay? Bless you. Okay. What is the formula for the area of a rectangle? Length times width. Okay? Now I'm going to, or base times height, depending on how it's sitting. We're going to look at this in kind of an unusual way. I want to talk about first the width. Okay? The width, of course, in this case will be horizontal. Do you agree with me? Okay. Are all of these rectangles approximately the same width? Yes. So we can give it all the same variable name. And we're going to call it a change delta. What do you think? Delta x or delta y?
X, because it's sideways.
Because it's sideways, it is delta x. Agreed. Okay. Now, usually when you say width and length, but I'm actually going to say width and height because the height is vertical in this case. Now, here's my question to you. Height has to deal with y values, and the only y values I have are f and g. Can you give me a way to say how tall these rectangles will be using f and g? Okay, I'm hearing a couple of people guess, but I want to give the rest of you a little bit of guidance. Okay, so let's take a rectangle that's completely in quadrant 1. Say this one right here. Find one of yours that's in quadrant 1. I'm going to shade it in. Okay, let's give it some number values. Let's say that this value here is 9, and this value down here is 1. How long is that side of the rectangle? If it's 9 units high here and 1 unit high there? 8, right? What did you just do to those two values? Subtracted them. So it sounds like it might be f of x minus g of x. That sounds like a good theory. Will that work if part of the rectangle is in quadrant 1 and the other one's in quadrant 4? will f of x minus g of x still work? Let's say that this is 5 and this is negative 2. If you subtract those two, will that still give you how tall the rectangle is? 5 minus negative 2, does that work? Yes, it does. Okay, what about if it's all down here and it's all negative? What if this is, say, negative 3 and that one's negative 7? Does subtracting still give you the length of that? Yes, it does. Negative 3 minus negative 7 is 4. So we can say that the height is going to be f of x minus g of x no matter where the curve lies. Just squeeze that in there. It's always f of x minus g of x no matter where the curve is, whether it's all in quadrant, whether it's positive, negative, it doesn't matter. That's why I had to draw it this way, so we could look at all the different possibilities. Okay, so to put it together without calculus, this is what we did when we first learned Riemann sums. We added up all the rectangles, that's a sigma. We started at A, and we stopped at B, and we added up all the areas. So we would say minus g of x for the length times delta x for the width. Okay, so that is the non-calculus way to write down in mathematical terms what we did. Add up all the rectangles from A to B by multiplying their length and width. Okay, so with calculus, which takes into account all those little pieces we had to cut off, the area is equal to the integral, which is the sigma stretched out into an S, from A to B, that's because there's an A on the bottom and a B on the top, of f of x minus g of x. And what do you think the delta x becomes? What do we always put at the end of an integral? dx. dx is delta x. That's why it's there. So this is the non-calculus way, this is the calculus way we do it. Because that represents the length, that represents the width, and that says add them all up from A to B. That's what we're doing. Okay? Questions? All right, now we're going to do a few examples, and I'm going to show you specifically what the AP exam wants you to write down when you do these. So I'm going to draw a line right here. Example. We're going to take two curves, y equals secant squared of x and y equals sine of x, from x equals 0 to x equals pi over 4. Sometimes they will tell you A and B, but honestly most of the time they won't. So I'm going to start out by one giving you the A and the B, and then I'll show you one how to find them yourself if you have to. Okay, so the first thing you must do when you do these problems is sketch a graph if they haven't already given you one. Now most of the times they won't. So what I need to do is I'm going to leave some space over here for my graph. I'm going to write down which equation I'm putting into y1 and which equation I'm putting into y2. This is very important. So I'm just going to put them in the order that they're given. Secant squared of x is going into y1. Sine of x is going into y2. But I have a problem. There is no secant button on the calculator.
You just do inverse.
No, you don't do inverse. You put in 1 over cosine of x, the quantity squared. Very important you put it in this way. Okay? So, this is going to tell you how to set your window. We'll take care of that in a minute. So let me bring over the calculator. I didn't clear it. Let me clear it real quick. Second plus 712. Yes. I was going to mention that in a minute. 1 divided by parentheses, as I type cosine, parentheses, cosine x, close twice squared. It's important that you close twice. And then for the other one, you type in sine of x. Okay? Everybody needs to be following along with me. Okay? Now go to the window. You need to type in 0 and pi over 4 for your x's, because that's what it told you the x's needed to be. For the y's, so that we're all looking like the same thing, trig functions tend to be small, so we're going to go from -3 to +3. Before you graph it, if you are in physics, please make sure your calculator is in radians, because otherwise it will not graph correctly. So if you're in physics, go check and make sure you're in radians. If you are, then push graph. Okay, you need to now sketch this on your paper. So I'm going to move this over to the side. I only have a left-hand axis here. So I'm going to go like this. I'm going to go like this.
Wait, so what did you say you wanted to?
0 to pi over 4 for the x's, and -3 to 3 for the y's. Okay. I noticed if I lean back a little bit, it brightens up the screen so you can see better. Okay. Ooh, I forgot to say something very important. I need to go back. Has everybody got this drawn? Okay. Come back up here. Let me reiterate. It's f of x minus g of x. Does this tell you which one is f and which one is g? No. What you need to think about is this. When we did this graph up here, it was always the top curve minus the bottom curve, and that's what I want you to remember. So under here, I want you to write top minus bottom. Top minus bottom. Okay, and we note that as we do the problem. Now, which one of these two is top and bottom? Let's say you weren't watching it when it graphed. I don't remember which one's top and bottom. Just push the trace key. Push trace. Which one is it blinking on? Y1, and that's the top curve. So out to the side, I'm going to write top here, and I'm going to write bottom here. Okay. So when we set up our integral, I'm going to show you the two ways the AP exam is happy to see it. You put your integral symbol. You write in your 0 and pi over 4. You can write the functions themselves in, the top minus the bottom. So you would write secant squared x minus sine x dx. That is totally acceptable. And then all you have to do is type that in the calculator and get the answer. The other way you can do it, which I prefer because this is actually what you're going to be typing in, you put the 0, pi over 4, and you put in y1 minus y2 dx like that. As long as you have written on your paper which equation is 1 and 2, you can write it on the test as y1 minus y2 because you denoted up here which one is which. And that's actually what you're going to type into the calculator. Okay? Now, so what I need you to do is take your calculator. I'm talking to those of you with 84s right now, just for a second. Go to the home screen. Where is the definite integral? Where do we push? Math 9. Very good. So if you have an 84, this is what you'll see. You're going to type that exactly in there. So 0, right arrow jumps up to the top, then pi over 4, right arrow. Do you remember where the y's are? Alpha and trace. Alpha, trace, and then enter. By the time you finish this worksheet, you will never again ask yourself where y1 is because you're going to type it so many times. I'm not kidding you. Minus. Okay, alpha trace again. Now, unfortunately, you can't type a 2. You've got a down arrow to get the y2 and push enter. Oops. I accidentally pushed enter twice. And I need an x right there for the dx. That's why it gave me an error message. I hadn't told it that. Push enter, and there is your answer. And you just write equals and write the decimal out to the side. 0.707. Make sure you go 3 decimal places. That's all the AP exam wants. Okay? Now, raise your hand if you're using an 83. I will explain it because I actually want to put it on video. So, real quickly, I need to change my mode because there are people who watch this video who are not at Reagan, or they go, I've got an 83, I don't know what you're doing. You've got to push Math 9, and it gives you this, FNINT. Then to get the y1 for you guys, and this is also a backup place for the 84s. It's also in the 84s here. You push the vars key just to the left of clear. And from there, it's pretty intuitive. You want a y variable, you want a function, you want y1. So you just push those sequence of buttons. Minus, do it again, vars, y vars, function, y2. And then you have to type in comma x for the dx, comma 0, comma pi over 4. Close your parentheses, and there it is. Okay? So those are the steps that you follow if you have an 83 calculator. Do you have any questions? Okay, let's move on to another example. One where I don't give you A and B. You're going to have to find them yourself. Next example. Y equals 2 minus x squared. Y equals negative x. There are your two functions. They didn't tell me from here to here. That means that you will have to find them yourself. Okay. If they don't give you an interval, they will definitely intersect. So the first thing I'm going to do is go to y equals, and I'm going to type these in.
How do you know what intersect?
Because if they're asking you to find the area between two curves and they don't tell you where to stop, they're going to intersect. So I need to put my calculator back in the right mode real quick. Go to y equals, erase what's there. 2 minus x squared, and then negative x. Zoom, let's talk about zoom. Kind of jumping the gun. If they don't tell you how to set your screen, I recommend that you type in zoom 4 for starters. Zoom 4 is a good default window to set. So push zoom 4. The reason being, I'm going to wait for it to finish graphing. When you do zoom 4, if you trace it, watch the x numbers. They go up in nice pretty increments of 0.1. So you can always likely land on 1 and 2 and 3. If you trace on zoom 6, you get really weird decimals when you do. That's why this is good. Okay? So I'm going to go back to graph. I'm going to come over here and I'm going to sketch this thing. There we go. So sketch it the best you can. I've sketched it 3 times today. That's why mine was just real quick. Whoosh, I got it done. Okay. I didn't do it on the last one, but I'm going to do it on this one. I'm going to move the calculator aside because you guys can see my graph. I want you to draw vertical lines in here like you would be drawing rectangles. And there's a reason for this. It's really not going to make a difference today, but it will tomorrow.
So do you always actually?
Okay. This is a way to basically shade the area we're talking about. Now, the reason I draw the lines in is to double check and make sure that every time I draw a line, I am going from one curve to the other curve. Because eventually you may come across one where you're going from one curve back to itself. And that's a problem. I'll show you how to tackle that in tomorrow's lesson. But as I drew my lines, did I always go from one curve to the other curve every time? The answer is yes. So we're good to go. So I'm going to write y1 equals 2 minus x squared. y2 equals negative x.
So without the calculator, would you just have to take the integrals by hand and plug it in and everything? So like, because you said they're teaching how to do it with the calculator?
Yes, you would have to go through and do antiderivatives and do it that way. Yes. Okay. Now the question bit is, which curve is the top curve, y1 or y2? The parabola is, correct? So this is top, this is bottom. You don't have to write that down, I just recommend that you do. So now, when you set up your integral, you're going to put in the integral from y1, the integral of y1 minus y2 dx, top minus bottom. I got a problem though. I don't know what numbers to put in there yet, okay?
Find the intersect.
So we're going to have to find the intersect. Never, 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 never assume it looks like, what does it look like that one's going to be? On the one on the left? -1. Don't ever assume. It could be 0.997, and if you put -1 and it's 0.997, you're going to miss the problem. Okay? So, trick you may not know about the intersect. Everybody, 83s and 84s, do the same thing. Push second, trace, intersect. You learned this long ago in Algebra 1. First curve, just push enter. Second curve, just push enter. You do not have to scroll to the guess. Type in what you think it is. I think it's -1. Push enter. Yep, it's -1. So now I can write -1 on the bottom of my integral. Okay? I want you now to go back and find the right-hand limit. Do the intersect and guess where it is. So to find A and B, you do second, trace, and intersect. Okay? And I wrote down how to do it. To find A and B, you do second, trace, and intersect. Okay? I need to ask a very important question since I am totally focusing on calculator today. Let's say that this problem gave you the two functions, gave you the picture, but did not allow you to use a calculator. How could you find the A and the B by hand? You set the two functions equal to each other because you're trying to find out where they're equal. So you would set them equal to each other. It's a quadratic. Set it equal to 0 and factor it, and it would give you the two numbers. So, do I need to say that one more time? Okay. If you had to do this by hand, you would set y1 equal to y2 on paper and solve for x. And when you do, you'll get two answers, and they would be A and B. Okay? All right. So now that we have this, I want you to type this in the calculator right now on your calculator. Type that in right now, get an answer if you haven't done so already. This answer is 4.5. Now, I am quickly going to do the last problem before we get caught by the bell. Example, real quickly. Y equals 2 cosine of x. Y equals x squared minus 1. I'm going to put it down here so you can see better. That's much better. 2 cosine x, close parentheses, x squared minus 1. Do a zoom 4 again. Zoom 4 is always a great place to start. Yep, got a great intersection right there. Slide it over here, draw it. I'm about to there's more to it that you need to know, so just hold on. No, it's supposed to intersect above there, but that's okay. y1 equals 2 cosine of x. y2 equals x squared minus 1. Okay. Don't try to jump ahead of me because I need to show you what to do when these intersection points are ugly. The AP exam requires that you keep every single decimal on those intersection points, and I'm going to show you how to do that. Okay? First of all, which curve is always on top? y1 is this time. It's not always going to be that way. So, y1 is on top. So I know it's going to be the integral of y1 minus y2 dx again. Okay? So what I need you to do is I want you to go ahead and go through the steps and find the left intersect point right now and just stop at that screen right there. Second, trace, intersect, enter, enter. It's close to -1. Okay? So I'm going to write down -1.265 ... This is what the AP exam wants you to do. Okay? Now I'm going to show you something kind of cool about your calculator. Since that's the left intersect point, that's A. Like A to B, it's the A, correct? I want you to push second quit, and I want you just to type an X on the home screen and push enter. There is that number that was in there stored for X. So what we're going to do is we're going to tell the calculator, I want you to make that number A. So you're going to type an X again, then the store key, alpha A. Okay? And on your paper, you're going to write an arrow and A to show that you've stored it for A. You have to keep all the decimals or they will not give you credit for the limits of integration. Okay? Now do the same thing for the right-hand intersect and store it for B. Okay? So you go ahead and do that right now. Go back to the graph. Second trace intersect. Enter, enter. Looks like it's about 1. Go back to the regular screen. Type in the X. Store alpha B. And write it down. 1.265 dot dot dot. Arrow B. Are you following me? I know I'm going quickly. I'm trying to get done before the bell. Okay. When you do this on the AP exam, you have one of two choices. You can write negative 1.265 dot dot dot. If you don't write dot dot dot, they don't give you the credit. Or make your life simple. Write A and B. Because now they know that you stored all the decimals for A, you stored all the decimals for B, and you're good to go. So now, everybody in here, on the home screen, I want you to type in the Math 9, putting in the A and the B, and then the Y1 minus Y2, and see what you get. What'd y'all get? 4.995.